Hey everybody, welcome to Algebra 1-2, section 11.3, dividing polynomials. By the end of this lesson, you should be able to divide polynomials by a monomial. You should be able to divide polynomials using long division. However, they've removed this standard, so we are not going to cover this. So this section should actually be very short. All right. So let's talk about dividing by monomials. Now, this is something that we've done before in Chapter 8, I believe, just the quotient rule. So we take a look at, we've got one monomial divided by another, and the rules are you either divide or reduce the coefficients. So the 12 divided by 3 just makes 4. And then you subtract your exponents. So x to the 5th and x squared, 5 minus 2 is 3. So 4, x to the 3rd. Okay, that's the quotient rule. So now let's go ahead and take that and apply it to something that looks a little bit different. What if we have a polynomial divided by a monomial? So let's say I had something like this. So I've got 12x to the 5th plus 3x to the 4th minus 15x to the 3rd, and all that's being divided by 3x squared. Well, since 3x squared is dividing everything, let's visualize that a little bit better. Let's take that 3x squared and let's put it underneath each term. Just kind of a reminder that each term is being divided by 3x squared. Then all we have to do is just focus on one fraction at a time. So let's go ahead and start with the 12x to the 5th over 3x squared. The 12 over 3 makes 4. We've already done that. And then x to the 5th over x squared makes x to the 3rd. Okay? So that part we've already established, but let's do the same process to the other fractions. So what if I've got 3x to the 4th over 3x squared? Well, the 3's are going to cancel out. And so, I mean, you could put 1 there and then subtract your exponents, and we get x to the 4th over x squared. That just makes x squared. But of course, 1x squared is the same as just x squared. So then we move on to the next fraction. So negative 15 over 3 reduces down to negative 5. And then x to the 3rd over x squared just makes x. Okay? So sometimes when we divide by a monomial, it works out perfectly just like this. Okay? Sometimes it will, sometimes it won't. So let's go ahead and take that as our final answer and look at a different problem. What if I have something like this? I'm still going to do the same process. Everything is being divided by 24x to the 7th. So I'll put that 24x to the 7th underneath everything. And then just look at one fraction at a time. So 48x to the 13th over 24x to the 7th. The 48 over 24 just reduces down to 2. Then subtract your exponents and you get x to the 6th. So far, so good. Let's move on to the next fraction. So 8 over 24. 24 does not go into 8, but 8 over 24 can reduce to 1/3. And then you take a look at x to the 7th over x to the 7th. The x to the 7ths cancel out. So that's just going to be 1/3 as your middle part of your answer. So then let's move on to the next part. Negative 120 x to the 4th over 24 x to the 7th. So negative 120 divided by 24, that actually turns out to be negative 5. And then x to the 4th over x to the 7th. Well, where do I have more x's? On the bottom. How many more? 3. So I put x to the 3rd on the bottom. So the purpose of this example is to show you that it is possible in your final answer that you can have individual fractions as part of the answer. So in our first example, everything worked out perfectly. In this example, you still have fractions. And that's okay. The main thing is that each term in the numerator got divided by that single denominator. Let's look at a few more examples and really get a handle on this. So here we've got several examples. We're not going to do all of these, just a handful of them, but just really want to get a handle on what we're doing here. So question number 1 shows you this polynomial divided by 9r. So what I'm going to do is I'm going to divide each thing by 9r. And then just do one fraction at a time. So 18 divided by 9 is 2. r to the 5th divided by r is r to the 4th. 36 divided by 9 is 4. And then r to the 4th over r is r to the 3rd. 27 divided by 9 is 3. And r to the 3rd over r is r squared. So there we go. That's my final answer for number 1. Let's take a look at question number 2. Okay, that whole polynomial being divided by 9x squared. So I'll put 9x squared underneath each thing. So for the first fraction, the 9's end up canceling out. And x to the 5th over x squared is x to the 3rd. On the second fraction, the 9's cancel out again. And x to the 4th over x squared is just x squared. The last fraction, 45 divided by 9 is 5. And then x to the 3rd over x to the 2nd is just x. And that's my final answer. So far, the first 2 examples have worked out perfectly. But that's not going to happen all the time. Let's take a look at number 4 here. Let's divide by 9v to the 3rd on each thing. So on the first fraction, I've got 3 over 9, which reduces to 1/3. And then the v to the 3rds cancel out. So that whole first fraction just reduces down to 1/3. Bring over my plus sign. The second fraction, there is no coefficient in the numerator, so that 9 just stays in the denominator. And where do I have more v's? I've got one more in the denominator. And since there's nothing left in the numerator, I'll just put a 1 there. The last fraction, bring over the plus sign. 2 over 9 can't reduce, so I'll just leave it as 2 over 9. And where do I have more v's? I've got 2 more in the denominator. So 9v squared. Okay? So in this one, nothing worked out perfectly. I had fractions for all 3 answers. And sometimes that's okay. Let's do, oh dear Lord, let's take a look at question number 8. That whole thing is being divided by 6kmn. If you can do this problem, you can do any problem in today's lesson. So let's just do this one. Let's break it down little bit by little bit. All right, so for my first fraction, I have 9 over 6, which can reduce by 3, so that makes 3 over 2. Where do I have more k's? I've got 2 more on top, so k squared. For the m's, again, I'm just doing this one thing at a time. So for the m's, I've got 1 more m on top, and the n's cancel out. So there's my first fraction. The second fraction, 3 over 6 reduces to 1/2, so I'll put a 2 in the denominator. I've got 1 more k on top. The m's cancel out, and I've got 1 more n on top. So kn over 2 is my middle fraction. Bring over the plus sign. 54 divided by 6, that works out perfectly. That's 9. So I want to put that 9 in the numerator. The k's cancel out. I've got 2 more m's on top. And the n's cancel out. So that last one's not even a fraction. It's just 9m squared. But all 3 of those things together make up my final answer. Okay? So again, if you can do that problem, you can do any problem. And we're going to skip the questions like this, where it's a polynomial divided by a binomial. So that being said, if you guys have any questions, please feel free to email me. Either email or ask me questions in class, either way. And I'd love to be able to help you. But in the meantime, you guys stay safe, have a good one, and I'll see you real soon.